Hi everyone, good evening, and thank you again for joining this Azure Data Engineering meetup. Tonight we have Jeff, who's from Astronomer, and he will be talking about orchestrating data pipelines with Apache Airflow on Azure. Really looking forward to it. If you have any questions during the talk or the demo, please put them in the comments or and leave a comment in the chat box. And then I'll make sure that we will discuss the question with Jeff either during the talk or maybe at the end. So Jeff, if you would like to give a small introduction, and then we can go ahead with your talk.
Great. Thanks. Thank you, Brian. Also, thank you very much for giving me the opportunity to be doing this presentation tonight. I'm going to be focusing on how to do data orchestration and orchestrate data pipelines with Apache Airflow, and specifically focusing on how you can do this inside the Microsoft Azure platform. So yeah, happy to take questions, happy to keep this interactive as we go. A little bit about me. I know I say I'm a data scientist, but that's just my joke about the fact that I'm not really a data scientist. My technical, my title is the Director for Field Engineering for Machine Learning at Astronomer. We'll talk a little bit about Astronomer as we go, so I'm not going to get into too much detail about that. But hopefully at the end of this, you will understand how data orchestration works using Apache Airflow. You'll have a bit more detail about Airflow. You'll be able to run and start building your own DAGs and testing them locally, and you'll understand how you can move that all the way through into production on Azure. So the agenda for today is going to be, we're going to do a quick introduction, kind of an Airflow 101. Then we're going to talk how you can get up and running locally so you can start testing and doing your work on your local machine. We're going to talk about how you can take what you've been doing to production on Azure and different deployment paths for that. And then a little bit more as to where you can go and learn and get some more information about things. So the starting point for this is an introduction to Apache Airflow. Apache Airflow is an open source tool for managing, authoring, scheduling, and monitoring data pipelines. And a data pipeline is kind of what you can think of as a series of steps to move data between different locations, or transform it, or filter it, or do something specific with your data. It is one of the most popular projects on the within the Apache ecosystem. I think this slide is actually wrong. It's about 12 million downloads per month at the moment. And it has eclipsed Spark as the most popular Apache project. And I think it's up at the top on GitHub as well. I think maybe Kafka is at a similar level. But it is a very, very popular, well-known, and pretty much the default standard for data orchestration in a business context. And it is all written in Python. So if you understand Python and you can do all of your work that you need to do, it is very customizable and extensible. There's lots of customizations that you can use to do things that are specific to you. It is scalable and can grow out. And we have customers that are doing this across hundreds and thousands of nodes across very, very, very big infrastructure, hundreds and thousands, not hundreds of thousands. That's just a bit crazy. That's ChatGPT. And then it's a large, vibrant open source community. So it's a very big community of people, very open and engaging. It's very. I have become committed to Apache Airflow since I've joined, and they're very helpful, very willing to engage. So it's a good community to get involved with. The features specifically that we focus on is there is making the availability of a scheduler, and we'll talk about what these components are in a moment. But there's at a high level, there's the scheduler, which is the thing that schedules when your tasks need to run. There's different provider packages. There's something called the Taskflow API, which we'll get to when we have a look at some code. There's new capabilities around dynamic tasks. So tasks can have a variable number of steps as we go through. It has a very capable and functional UI. And there's a new functionality called deferrable operators, which I'll also talk to a little bit further as we go. Specifically what it's used for, and I think one of the things that's probably Airflow's best kept secret, is it gets used a lot for machine learning, and specifically for machine learning operations. And I guess part of this is in an enterprise context, most machine learning is probably classification and regression on tabular data. The big complicated TensorFlow things tend to actually not be as widely used in a large enterprise context. They're used, but they're not as widely adopted. And for those type of use cases, Airflow is ideally suited. It is very good at transforming and moving data through an ecosystem, an existing ecosystem of structured data. Its bread and butter is ETL and ELT, and also moving things for operationalized analytics. So if you have a report that you need to run and you need to schedule it so that runs once a week or once a month, Airflow is the place to do that, because it takes the data, runs any transformations that you would need to do, and then presents that report. An important thing to understand that Airflow is an orchestrator. So while Airflow can take on some of these tasks and actually do them itself inside the task that runs, and we're going to talk a little bit more about this as it goes, it integrates very well with all the other data tools, data science tools, data processing tools, machine learning tools, data validation tools, quality assurance tools, all of those things. It integrates and has very tight integrations with all of those different processes to do orchestration all the way through. So it is focused on multiple use cases. Anything that is moving or touching data that needs to happen on a regular basis, Airflow can do. So let's talk about a few of the core concepts and terminology. So when we'll be talking about things during the demo, we kind of are on the same page as to what we're talking about. The different components that run inside Airflow. So Airflow is a series of different services that run inside an application. And there's different ways of deploying Airflow. You can deploy Airflow just locally using the upstream Airflow. You can use the Astronomer command line tools. There are a bunch of different ways that you can do this. But the core components is a web server, so that's the web interface that you're seeing. The scheduler, so that's the actual task, that process that triggers a task that needs to run. So when you have a task that needs to actually activate, that would be running on the scheduler. There is a backend database that keeps the state of all the things that have happened. Then there's the thing called an executor, and that's the actual task itself, the thing that is running, doing what you've instructed it to do. So it can be running inside Kubernetes. It can be running just purely on Python on your local machine. It can be running inside something called Celery. There are lots of different places that it can run. You have the workers, which is the infrastructure that is actually running, the executors are running inside. And a new feature for Airflow is something called the triggerer. And if you're familiar with Airflow, there are processes called sensors, and their job is to go and check for something to see if it's available. Like let's say you got to change to an S3 bucket, but it might use up a whole executor. So deferrable operators or async IO is a new capability that says if a task is just doing a check and then going away, it shouldn't take up resource allocations for you. So in Airflow, there are new things called triggerers that run async sensors, which means check that if there's something in S3, if it's not, then go away and don't take up those resources. So those are the core components that we look at when we're talking about how Airflow runs. Everything
I see sorry. I see
Sure.
we have a question from Cornelia.
Yeah, not a problem. I understand the question. Right. So what is the difference between Airflow and Kafka? It's a great question. I get asked this a lot. Airflow is an orchestrator. So what Airflow is designed to do is in batches, you say, go and move some data between processes for me. Go and grab this table from Snowflake and trigger this filtering process over here, then extract some features and put it into Feast, and then instruct something to go and start doing a machine learning training process. So it is executing what we call a DAG, which is what we see on the screen. So it's a directed acyclic graph. So it is a batched process scheduler to manage things through a workflow. Kafka is what we call a message bus. So Kafka is a place where if you have lots of data that's moving quickly, so let's say in the IoT world, and you've got a whole bunch of sensors that are tracking things in a factory, all of those sensors are sending messages. What Kafka does is it acts as a message bus. So a topic will come in or a message will come in, Kafka will hold it until something on the other side reads it. So it's basically like a dynamic buffer for dynamic, fast-moving data. You can do things with Kafka using Airflow. So you can once a minute go in and read a bunch of messages, but Kafka is more for real-time data throughput. to go between something that's emitting data and something that wants to read it, and it acts in the middle as a buffer. Airflow is a data orchestration tool that goes in batches to go and do scheduled transformations and updates and changes to data that has already landed. So you may have Kafka that sits before Airflow. So a Kafka queue that writes it to maybe an HDFS, into an HDFS store, and then Airflow would pick that up and then transfer it maybe to Snowflake. So they are fundamentally they are part of a bigger ecosystem, but they do different things. Hopefully that answers your question. So a DAG, which is a directed acyclic graph, is a series of tasks. So you have a bunch of different tasks. Say, I want this task to then trigger 2 downstream tasks. When they complete, I want this task to complete. But it has to start at one end and come to a completion. It has to move all the way through. And that's specific to be directed acyclic. So acyclic means that there's no cycle behind it. This one is invalid because task 4 goes back to task 1. No task can go backwards and call itself. So that is what a DAG is, a thing that runs. It starts at one end, completes at the other end, and then we know that this is the unit of work, which we would call a DAG in this instance, comes to an end. A task is one of those individual nodes inside the DAG. And the best way I think of it is when I run Python and I run a bunch of Python code and then I end my Python process, that's what a task does. So it's an atomic piece of work. It instantiates, it does a thing, and then when it's completed, it stops, and downstream other tasks can happen. The task instance is a version of a task that ran historically. So if I can say, can you tell me what the task instance was from 3 weeks ago that ran at midnight, that would be a task instance. So a DAG is made up of a series of tasks. Now, inside a task, there is a specific thing that Airflow uses called operators. And operators are a shorthand for doing specific things like you would normally want to do inside your workflows. So you may have something that I want to run a snippet of Python code, or I want to run a bash query. So if I just want to run something in bash, you have all of these different operators, and each operator generally is its own single task. And they're very specialized and do very specific things. And we're going to be using some Azure operators in part of our demo today. But there are operators for AWS services and for Snowflake and for all of those different pieces. So operators are a shorthand for creating Python functions or Python capabilities inside a task that are quite specific to the target environment that you want to use. So this, for example, the S3 to Snowflake operator is a single operator, and we'll have a look at how some of this code works as well. But its process is to take a file from S3 and then convert it into a data format and upload that to Snowflake. Then we have providers, and providers are collections of operators as well as the other bits and pieces that hang on to it. So you also have sensors, and you have hooks, and you have other few bits and pieces that are useful, but a provider is a mechanism, or it's actually a Python package usually, that wraps up a series of operators and some other utilities focused on something specific. So you can see here, we've got some for Google, some for Amazon, some for Microsoft Azure, some for Astronomer, and they are collections of providers that include these different operators. Now, DAGs are defined in software, so this is not a graphical environment. You need to go and code and build your code into the DAG. And we'll talk a little bit about the structure as well when we get into the demo. But this code is representative of what a DAG would be. So here we have a S3 to Snowflake operator to say you want to take something from this Snowflake table on that stage, but this is where the actual file is. So the file will be in that file format. We take that information. This is the S3 keys. So those are the keys that we need to be able to go and find where the file is. And we're going to push it to this table. And this is the identifier that tells us how we're going to go and connect to Snowflake. And this is an operator. So this is kind of the shorthand that you use inside your DAG code to go and create that particular process as a task. I will give you some links if you want to learn more detail about how to actually start building things in Airflow. But this is just kind of to give you a high-level overview of how things can work and what they look like. And DAGs all run inside the UI. So DAG here, you can see that this task of copying data from S3 to Snowflake is going to be triggered before the column check task. So this is the column check task, which is also an operator, and you put together things in a sequence. And you can see here we use the fancy right shift operator. That's how we chain things together in our workflow. So tasks are connected together in a DAG, and this is kind of the syntax you use to define your DAG. DAGs can get incredibly complex though. So you can have nested DAGs, you can have branches, you can have dynamic DAGs, you can talk to loads of different types of processes. So you can fetch data from Oracle and then transfer it, put it to S3, and then load it into Databricks, and from there load that into Snowflake and do the process that way. We've got another question. What is the preferred way of creating DAGs? Yeah, it's a great question. So there's the TaskFlow API, and then there's the operator-based API. I think TaskFlow is becoming more popular, but standard operators, if you're doing things that are very Pythonic, so if you're focusing heavily on Python, then TaskFlow becomes easier to read. They are the same. The Python operator and the @task decorator are fundamentally the same thing underneath. Airflow treats them as the same capability, but passing of data between tasks is just a little bit more easy to understand in the context of the TaskFlow API. So my suggestion is, if you're doing everything in Python and you don't need some of the shortcuts that the operators provide, then stick with TaskFlow. But there are some scenarios that we've had with customers where they won't allow arbitrary Python execution. So imagine you're a big bank and someone says, okay, well, I need you to run a data process on my data, but I can't allow you to run whatever Python you want to run, because maybe you can then do something that would go against regulatory requirements. So they pin down what you can run by giving you a pre-selected list of operators, and those operators can only do those things. So there is a place for both, and I sometimes mix and match between them, and certain things like running a bash, if I need to run a bash command. So sometimes I need to connect to a remote machine and run some kind of curl command on that machine. Doing that in Python with subprocess or Python SSH is more of a heavy lift than I want. So I'm inclined to use an operator in that case. And so I do mix and match. I think it's dependent on what goes inside the code. I wouldn't, if I'm just doing an S3 to Snowflake conversion, writing the Bodo3 connectors, making sure that you have all of the AWS credentials, writing the connections for Snowflake into that, having to build all of that boilerplate is a lot of work for what is essentially one function, which someone else has already done all the work for you. So you can just use the S3 to Snowflake operator. But if you're having to do something, and because I come from a machine learning background where you're doing model training and model training code, I tend to use the TaskFlow API. But there's no right answer. I think it very much depends on the situation you're in as to which one you would choose to use.
All right, thanks.
Sure. Okay. Alrighty. So we can have a look and we can see how we have a whole bunch of different things that Airflow can talk to. And you can be doing this based on whatever business use case you may have. Okay. So how do you get started with wanting to run and start building your first DAGs? So we, as Astronomer, have a open source and free command line tool, our CLI, that lets you get up and running with Apache Airflow. So we will send out the slides after this, but here's the link to it. You can also use Homebrew if you're on a Mac. So brew install Astro gets you up and running. And we are now going to demo this. So let me get let me get VS Code up and running. So once you have the Astro CLI installed, you can go Astro version. You can see we're on 1.11. So the Astro CLI does a couple of things. You have to have Docker, some form of Docker daemon installed. So on my MacBook, I'm using Docker Desktop. On Windows, you can use Docker Desktop. On Linux, you can use Docker D. Some people like to use Kalima. There is another one that I've seen people work with. Kalima, I know, is supported. Docker D and Docker Desktop are both supported. So those are the ones that you need to have running. And your starting point, your entry point into this, once you have the Astro CLI installed, is you create a new directory. You go Astro dev init. And this will initialize the directory you're in with our kind of scaffolding, the sort of standard set of files that you would need to use in order to be able to run. So I've done this already, and you can see it creates a bunch of files. So it creates a .github, .astro, a DAGs folder, which is where our DAGs will be, and a couple of other things, and a Docker file, which we're going to be using to go and build and create our process. Once you have that, the directory initialized, we need to now start up the process. So we run Astro dev start. Since I've already started it, it takes like a minute or two to start up, but you can also see what's running. So if you see, have a look, we have 4 processes running. And if I have a look at Docker, you'll see the same 4 processes are matched there. We have a web server, which is the UI that I'm going to be using, the scheduler, which is the process that goes and actually starts each of these individual tasks. We have the triggerer, which is then for the deferrable operators, and a Postgres database, which we're using kind of for backend state management. And if you want to go in and connect to this, you know, with Docker, you can do a Docker run, and it will connect you to a running process. We can actually run Astro dev bash, and it will connect us to our scheduler. And we have, what am I doing? Astro, no. It should be Astro dev bash. Get rid of view to there. Sorry. Then we go Astro dev bash, and this now has connected me to my container. So you can see that there will be PSAUX, there will be various Airflow processes that are running. There aren't separated workers. This is just using the standard Python executor running on my local machine. Now, I have a couple of DAGs that are in this folder, but I think the important thing to look at now is the UI. So here is the web interface that I would connect to. When you launch, it launches the web UI on port 8080. The login details are just admin. By default, we create these 2 DAGs for you, but this is the Hello World DAG that I'll be walking through in terms of the code demo. So if we go into this DAG, you can see there's a couple of things. There's a couple of tasks, and we'll go through the code for this. But if I want to trigger my DAG and have it run, I run trigger DAG, and the DAG's going to initiate. But let's go and have a look at the code and see how we got there. So the only file that I've needed to edit is my Hello World DAG file. And I needed to put in my DAG code. So there's a couple of bits and pieces that we can run through. So these are the various imports that I need to put. If you want, let's say you're running the Python, the TaskFlow API, there's a thing, and there's part of sort of Airflow best practices, and you want to import TensorFlow for a particular task, or let's say scikit-learn or something. That's not an Airflow thing. Airflow doesn't need to know about scikit-learn. Your task needs to know about scikit-learn. So you actually do those imports in this level here. So you can see I've put these in here inside that task, so that there's not a heavy lift for Python when they're for Airflow. Airflow doesn't have to import that. The Airflow process is going to import all of these, but it's only the tasks that will do those extra things. So that's just a kind of standard gotcha that a lot of people don't know about. But let's go through the code. So we have a bunch of arguments that happen for every task. And there are things like the number of retries, what to do if there's a failure, depends on past, meaning has this run before. There's a couple of things, and there's loads and loads and loads of information, and I'll provide you the links at that at the end. Then we have the actual DAG itself. So the DAG says the schedule. We use standard cron syntax, or you can use datetime syntax for scheduling. So if I wanted this to run every minute, it would be 0, 0, 0, star, star, star. And that's going to run once, I think that's once a day. So that's a daily run for that. But then there's also like standard things you can run. I think at daily will work. So it will know that that needs to run daily. But at the moment, I've set it for a schedule of none. So it's not going to be running at all automatically. I'm going to trigger this manually by itself. To be honest, this is probably the most important feature of Airflow, is its ability to run things on a schedule. So if we go back and have a look here, you can see what the schedule says. Let me actually see if I can get my cron syntax to work. 0, star, 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 and we save it. Let me have a look.
Hi, folks. I think we have a little bit of a technical issue. Yeah. You're back again, Jeff.
Yeah, I refreshed my browser.
Yeah.
The wrong browser.
No problem. No problem.
Sorry about that. Okay.
No problem.
Let me make sure I do this the
I'll
correct place.
add you back to the, and I'll remove myself again so you can continue.
Okay, so now you can see the schedule has now changed. So we're back on a schedule of minutely, so I think it's daily, so that's going to run. But that's the thing that we're doing in terms of specifying the schedule for the DAG. I'll change it back to none, so it doesn't keep wanting to update the GitHub repo. So this is a hello world task, and this is kind of old school operator implementation. We call this the Python operator, and we say this is the callable that we want to run, and this is the specific input value we want to put into this. And this is where things get complicated. And if you're just wanting to run arbitrary Python, I don't suggest you use the Python operator. I actually suggest you use the @task decorator, which you can see here. Because over here, I have this as my actual function that I want to run. This is the input value. This is the information. So it is simply going to add input value is, and then adds what tells you what that input value is. And then it's going to return hello world plus that input value. So it is a slightly strange process of having this defined over here, but then having the actual call to the thing that you're running defined separately. It is an artifact of how Python operators were not really the first things that were built inside Airflow. If you're doing that, your best way to do this now is to use the @task decorator. And if we go back here, you'll see that these two things are defined and look like the same thing. So one is a Python operator and one is a Python decorated operator. So that's a normal Python operator. This is a Python decorated operator. Inside the UI, you can see the code. So you can come and have a look, and you can see, have a look at how your code is running. And in here, we're going to go and run a task. And what this task does is it's going to use Beautiful Soup, and it's going to connect me to this website. So this website says, has the Large Hadron Collider destroyed the world yet? Let's just make sure I go there. And the answer is no. So we're still good. And what this does, this task is going to go and grab that URL. It uses Beautiful Soup, goes through the parser, looks for the first no script thing, and just returns the string. So it is from my Python task that's being instantiated. It's reaching out, it's fetching the HTML, it's parsing the HTML, and returning one specific tag for me. This is the information. Okay, question, does it have a VS Code extension? It does. There is a VS Code extension for, it's actually written by one of my colleagues. I'm wondering if I have it installed. Extensions, yeah, here's the Airflow templates. And Airflow templates specifically helps with code completion for operators. So there is one, and it helps you then just do automatic code completion inside things that is operators that it knows about. I don't actually use it that much because I tend to actually focus more on task-based Python implementations. But if you are using standard operators, it is just a template that will auto-complete and give you all of these things that are the things that you need to know about. So this task is going to go and fetch that information for you and return it. And if we have a look here, there's a couple of things that are worth knowing. So if we go into the graph view, let's have a look at the log from this particular run. So you can see inside here, it's saying to me, the input value is hello world and the return value is hello world exclamation mark. So what we've done, we've taken the input value, we're just printing that out for our use. And then this is the return value. And the return value goes through something called XCOMs. And what XCOMs is a way of passing data between tasks. Now, in standard Python, this is not a problem. You can actually very easily take just hand data between things because Python keeps a memory map. But these tasks act entirely independently. They are their own Python processes. A task may be running on a different machine on a different continent with no way of sharing that memory. So XCOMs is a mechanism for passing data between those tasks. It's a standard common problem with Airflow in that it struggles to deal with anything that's not easily serializable data. And one of the things that it can't deal with very well is very large pandas data frames. And it uses the actual database as the mechanism. So it will write that hello world as a value into the database so that the downstream task reads from it. You as the developer don't have to do much work on it, but it does realize this, but it does have the limitation that it's not really capable for parsing large data sets. We as Astronomer have created some things to fix that. So we have this thing called the Astro Python SDK. It is a demo for another time, but it is a way of fixing this to make it so that you can parse very, very large data sets between your actual Python tasks. But in a standard like ETL world, or if you're triggering Spark jobs, you need to know some information, but you don't actually want to hold the data with you. And if we go to the next stage here, we can have a look at this task. We have a look at the logs. So the logs here are pulling down. It basically is just grabbing the, if we have a look at the code, you can see that I'm actually doing the printing it out. I found this really great. If you actually have a look inside this, there's a hidden tag that tells you what's going on with this, the laser-eyed bunny. But it then fetches that information, returns the value for you. And if I go back into the XCOMs for this, it will say nope. So we have created a series of steps. We can debug by looking at the logs for anything that we want to do. And then we can specifically go and pass data between those tasks. That's standard Airflow, standard orchestration. I'm doing things in Python. But because we're talking about Azure, there are specific Azure container, there are specific Azure operators. Now, the best place to find out about different operators and how to use them is the Astronomer registry. I wish it would not do that. Okay, registry.astronomer.io. So here we can go to, is just a collection point for different places. Let's allow all. Different places that it's a collection point for different operators and providers, but there's also lots of guides and tutorials and information specific to Airflow about how to do certain things. So if we're looking for things on Azure, let's go and have a look. This is the Microsoft Azure provider. And I said there's operators, and operators are the things we have the most of, but there's sensors, hooks, etc., secrets, those type of things. For operators, let's say we want to run something that needs slightly bigger memory and slightly more separation from our standard Airflow environment to be able to run. There is an operator called the Azure Container Instances operator. And what this does is we'll connect to an Azure instance, spin up an ACI container, and then execute some code inside it, and then let it die and delete it when it's completed. You need to provide a bunch of the information for how it makes the connection, but inside your Airflow instance, you would be able to run and implement that. So in this DAG here, I have a process. Let's go back to my graph. I have a process that just simply runs a container. So it connects to the container spins up, and it just executes the default command for that container. The container then goes away. How do I know, how does Airflow know how to get there? We have something called connections. And in this particular connection, I've created my Azure container connection. So if we want to have a look, here is the Azure container, the connection type is an Azure container instance. There's a couple of things that you need to provide. I know I'm rushing through this, but, and this is also in the list of links we'll provide at the end. If you go to our documentation, there's a section on learning, and you can have a look at tutorials. We talk about integrations with Azure container instances. So here is a 30-minute tutorial that you can walk through yourself that will show you how to actually build it up, how to set it, how to get it going, all of the steps that you need to do so that you too can build yourself the connection information, and then you can run this DAG. So let's trigger this DAG again, and next time we're going to watch what happens over here. So while this is running, it's going to try and spin up the containers. The first two tasks are going to run, but now we see that this task is running. So if I go here to my container instances, and we refresh it a few times, at some point, a container is going to appear here that has been orchestrated by my Airflow task. I'm not doing anything specifically interesting with that container. There we go, it'll come up in a mo. Let's have a look here. What is it saying? Oh, it's actually run. It came and went, and I missed it. It's in between a refresh. But it ran the Docker image. You can see here, there's a couple of errors that came out because it was waiting for it to instantiate. But it ran and then it killed it and it deleted it. So it was very quick. I actually didn't even get to see it here in the list while it was going. But it was in this process that this container would have run. I am using, if we have a look at my code, I'm using the image here is the Hello World latest, and it just simply responds with this. I told it I'm in Western Europe, a couple of things that I need to set up, and this container would run. So if you create a custom container, and you can also actually add a command feature here. So command equals, let's go /bin echo, whatever you'd want to do. But this actual container doesn't have an echo function. It doesn't even have bash. I was quite surprised at how lightweight it is. But it is just a hello world one. You can also specify the size of infrastructure that you want to run. You can specify GPU if you want in here. So you can get quite fancy with this. You can also pass information into it. So if you have a link that you've generated to an Azure blob storage somewhere, you can provide that link inside this information here. So something in the command, maybe it would then go and fetch it. You can also, if you have a look at the more detailed Azure container instantiation information, you can specify environment variables, volumes to mount to. You can get quite complicated with this. So you can have something that runs as a small task and then a much bigger task that needs to run. So say maybe you're doing GPU-based training, that would all be able to run inside a process like this. So we can have a graph view of it. A grid view just allows you to go back and have a look at things historically. There are things that you can rerun. You can mark things as failed if they didn't work. You can go to a particular task inside the grid view and you can say clear and it will rerun it for me. So it's now going to go and rerun that task because if I wasn't satisfied with how it ran, there are a lot of features and capabilities that are accessible to you inside the UI. And yeah, so that's how you get a local instance up and running. Is there an Astronomer extension? That's a good question. For VS Code, no. We actually haven't created an Astronomer extension yet. I think there's Astronomer stuff from the Astronomer CLI. It's actually a good question. I don't know why we don't specifically have one, but there's probably something that I would imagine it's in the queue. More of the development work for this type of stuff tends to happen in open source Airflow rather than Astronomer. But let's take a look at what you get from an infrastructure perspective. So how do you deploy this into production on Azure? Well, there's three approaches that you have. The first one is you can do this as DIY on a Kubernetes cluster. So if you use AKS, you can go and create a cluster and there's open upstream Airflow Helm charts that will let you go and install. You can use some of the cloud native deployments. So the cloud native deployments, there's managed Airflow and Azure Data Factory. There's MWAA, which is the AWS version. There's GCC, which is the Google version. And then there's Airflow from Astronomer. So we also provide a managed infrastructure. We deploy onto all three cloud providers. So we will deploy into Azure for you and manage that infrastructure on your behalf. So you can do the Helm chart. So there is a Helm chart for Apache Airflow. This is one of those things, I think, where we have a lot of the customers that have come to us have started here and realized that there's just more work to it than they want to do. So they want to focus on writing DAGs, not on doing RBAC upgrades for integration to Active Directory. That's what our engineering team does and focuses on. So that's where is basically you're handing over that type of requirement and capability to someone else. There is the Azure Data Factory version. I've got to say it's very new, so I haven't actually used it. So maybe, Bram, if the question comes in about how it works, you can share some of your experiences there. And then there is the Astronomer version. So Astronomer, and this is just like 2-3 minutes of our standard pitch deck as to why you would want to use Astronomer for managing your workflows or your Airflow instances. So as I said, I think, yeah, we're at like 16 million downloads at the moment, a month for Airflow. So Airflow is huge. We have a Slack community. We have 2,300 contributors, of which I'm one from one contribution I made about 6 months ago. And it's a fairly large, group of people. Astro, in our opinion, is the best place to run Airflow because it's reliable, it's scalable, and productive. We have two modes of operation where you can give us an account that we can connect into and build, or we can host everything for you in the cloud provider of your choice. The reliability is because we provide the most recent version of Airflow, a secured version of Airflow that you're able to run. So we have an image that we're running. It's a Docker image that is the same one that you'd run on the CLI, is the one that will get deployed. We have CI/CD integration, and we monitor this process all the way through. And one of the things that we do with upgrades is zero downtime. So if you're going to upgrade your Airflow instance, there is no downtime for it. Scalability is we have auto scaling on all of processes. So we make sure that we not only can scale up to the needs that you require, we can set limits on how big that needs to be. And we can also help you optimize on cost. So there's a lot of capability that we bring in with scalability to be able to make sure that you can go from your starting point for a well-priced Airflow instance in production all the way up to hundreds of Airflow instances across multiple zones, across millions of tasks per day. So we do scale, and we have customers that scale up to that size. And our development mechanisms allow for increased productivity. So there is a path for local development, and we'll show how you get from local development through to production in a kind of programmatic workflow way using our CI/CD processes. And we have our support. We have 15 out of the top 25 contributors to Airflow work at Astronomer. So if you're looking for support just for people who understand Airflow very, very well, we're the place to come, because part of what you get when you take the service with us is additional support for it. There are two additional features that come with our capabilities that aren't necessarily included by default in Airflow. One, we'll have a quick look at these as we go. One is something called our Cloud IDE, which is a cloud-based editing tool for DAG authoring for people who don't really want to get into the depth of DAG code. So it's an abstraction. In fact, to be honest, most of our big customers don't let their users author DAGs directly. They either go through some kind of intermediary YAML compose or JSON compose. And we have a mechanism that allows you to write Python and SQL and not have to think about how that actually works underneath. And we integrate data lineage. So Open Lineage is integrated with Airflow. We provide lineage built into the service that we sell, so you can automatically use it. Okay, so architecturally, we have our control plane that connects to a cloud infrastructure, whether it's yours or owned, looked after by you or looked after by us. It runs the same process. We deploy Kubernetes infrastructure into that environment, and from there, we connect to your various external data systems, so you're able to go and connect and operate. So let's have a look at how that looks. This is the starting point. Yeah, question.
Yeah, it was more a question for me. If you deploy it on a Kubernetes cluster, do you make use of AKS?
Yes, we do.
Okay.
Yeah, so we do. We use the cloud native Kubernetes provider when we do our deployment. So that information, let's have a look. Astro, Azure. So all on Azure, and this talks about the prerequisites and what we build, and you can have a look at the reference. I think is a reference architecture that talks about how it works as well. But yes, it does use AKS underneath.
All right, thanks.
Yeah. So here is our interface. We have workspaces, and workspaces are a logical area of separation. So if I want my marketing team to have access to one thing and my finance team to have access to separate infrastructure, we do it that way. There is, we've actually deployed into different cloud providers for these different services. The cluster deployment is something that you don't see. So it happens in the background when you send a support request. But you can see that these are clusters that have been deployed into Azure. So this one is running on Azure, is running in central US at the moment. And this is the one that I am going to go and do my deployments in. So we have our dev workspace, and our dev workspace allows us to create multiple different deployments. And the deployment is effectively just an Airflow instance. So when I create a deployment, I give it a name, I select the cluster. So I want this to be on my Azure deployment. And I want to say the type of executor. So do I want Kubernetes or Celery? You can then pick the runtime, so the version of Airflow that you want to run. You can pick the type of nodes that you want to have added to it for your workers, and a couple of things you can tweak around this. And then you create a deployment, and that's going to go and create a deployment for you that I can connect to as an Airflow instance. So now this Airflow instance is in the cloud. This is my production Airflow instance. You can see I've got the same hello world DAG because I've gone through the process of uploading and deploying my DAG to that. But we connect our local instance to the deployed instance. So if I go here and I go Astro login, no, Astro login jeff.cloud.astronomer.io and jeff.fletcher@astronomer.io. Enter. It's going to open my browser for me, open in another window so you can see it, but I've now successfully authenticated. So I can now take these files and I can deploy them into production. So I can go Astro deploy and it'll push those files for me. And it'll say, right, which one do I want to deploy to? And you can see I have this JF Astro, but I'm actually not going to do it that way. I'm going to show you the other way that we can do this, where we do this via our CI/CD chain, where it just lets us deploy directly to GitHub, and from GitHub, it'll automatically deploy to that cluster for me. So that's actually the process that we're going to follow now. So I just need to make a change. One of the things that's worth noting, there is the requirements.txt file for any specific Python functions that you need to run. So in my hello world DAG, you can see I needed this. So I had to install that requirement. Our registry always tells you what you need to add to your requirements file. So it'll tell you what you need to import in order to get it to run. So that's the thing that you need to have. So this is in my requirements.txt file. So let me save this. That will tell me that I have one change. Does it tell me that I have one change? Yeah. Oh, I should have a change. Yeah, so I've got one change to add to my source control. So I'm going to say minor change, and I'm going to upload it to GitHub. So now I've synced this through to GitHub. And if I go back to my GitHub page, you can see here we use actions. So now I've triggered an action, and this action is going to go and do the same thing as if I do Astro deploy on my local machine. In fact, the actual automation runs the Astro deploy function. And the Astro deploy creates a Docker image, and it bundles that Docker image, pushes it to the cluster that we've created where we're running a container registry, and starts up a new Airflow worker running that new image, and slowly waits for the one in the existing Airflow worker to finish, and then it gets deleted. So the same thing that happens if I run Astro deploy locally is it creates that image. And I do this inside GitHub. GitHub Actions actually instantiates an instance or a node and runs this code on that node, and actually does it by downloading the CLI. So if we go actually to the top of this, we'll see one of the checkout repo. I don't think we actually go all the way that far back. But you see, yeah, so it's installing this. Yeah, no, it's doing it here. So it's installing the CLI here, and I have set up API keys. So if I go have a look here, we'll see that there's API keys. This API key is how GitHub knows that that is the server or instance that I need to deploy to. And this whole process is running and integrating, and will push the latest version of my DAG code through online. And we'll see here in a moment, you'll see it will start to update, but my DAG code will come to this DAG, and I have the same connection. So I edited and added the connection here as well. So if I go back and I trigger the DAG, the same thing is going to happen. So this DAG is running in production, in a production instance that's sitting on Azure, that's now going to go and instantiate my container. Maybe we can see it now. If we go in here, refresh, do we see it? Maybe. We might miss it. I think I actually got here too late already. Pending, waiting. Yeah, there we go. Maybe we see it now. No. Okay. I had to do it like I managed to get it twice today when I was testing this before we went. Okay, but never mind. It is happening. So that should be completed in a second. It's terminated. We're done. So this is running inside Azure, which is orchestrating against. In fact, it's actually in a different subscription. So the subscription that I'm containing my container instances in here, this is my field engineering one, which is the one that I use. but this is for dev, but there is a different subscription that we use where we go and deploy the AKS cluster to go and put everything into production. So that's how we get through the whole lifecycle process. Just two other things to show you quickly. So here we have our Cloud IDE. So our Cloud IDE lets me do and work on DAG files via editing inside cells. It's meant to have it look like and be more like Jupyter notebooks, but it shows you it automatically constructs the DAG for you. So the code is automatically constructed, and this DAG workflow is automatically constructed. I only really need to add and edit in either Python cells or SQL cells. And we say, this is connecting to Snowflake. This is the SQL query to run. Pass the SQL query over as a data frame to this Python function. This Python function knows immediately how to actually work with the previous data in the previous steps. And you can add a cell based on a type. You can actually create customized ones here as well. So if you want to run a specific old school operator, that capability is available to you as well. And the other thing that we have that's available inside the Astronomer instance is our lineage tool. And our lineage tooling is a way of, let's have a look here. Wait. Delivery. Maybe here. Hang on, I think I need to go back from this one. Do I go there? ETL. I actually didn't check this before we had a look, but it is access to the lineage tool delivery. Choose datasets. Delivery dataset. Do I have it here? Public delivery, food delivery. There we go. So this one, basically the lineage graph shows you where data came from and where it went to. So it's going to take a little while because it has to go back and view this historically, but this is how the DAG run works. So it shows you this was the input for that. This was the data inputs to it. This is the duration, and you can run a comparison to say, I want to compare this one. Let's actually go here. This is a slightly better one. Exit compare. Let's take this one and run a comparison between that one and one that I ran previously. And it can show you how things have changed. So how your code is changing over time. It is the integration into the lineage tool. I always think of this as an insurance sale. You want to use lineage when you have to use it. So it's there. It's not necessarily the place you're going to go and debug code. But if someone needs to say, how did this happen and how does it compare to a previous one? This is all integrated and happens automatically inside the Airflow system, inside the Astronomer system. So that is our production implementation. So this is a production implementation that's running inside Azure. It can run inside a secure Azure subscription that you would provide. We would just go and install and deploy everything inside that account for you. And we can start to use inside this operators made to run on Azure. Okay, so the last steps is additional resources. So these are the links, things that I called out as we were going. We will be able to send out this presentation to you afterwards. We also do have our Airflow certification process. So if you want to learn more about Airflow and actually get certified that you are an Airflow, that you have Airflow fundamentals under your belt, this is a program and process that you can go through. Alrighty, so thank you all. If there are any more questions, we can take them now.
Hey, Jeff. Yeah, thank you so much. Really cool talk. I really enjoyed it.
Thank you.
I'm going to really try out Astro CLI locally as well, see how it works. I was wondering, because how does Apache Airflow compare to Mage? I know that Mage has got a lot of traction at the moment on LinkedIn and on socials, and it's pretty new on the market. But and I know that Apache Airflow exists way longer, it's more mature. But how does it compare to each other, the products?
It's an interesting one. I don't know Mage. So the ones that I tend to see competitively are Dagster and Prefect are the ones that are the ones that we actually tend to compete the most with. Azure Data Factory, obviously. Then so there's Airflow competing with things, and then there's Astronomer competing with things. So from an Airflow perspective, it's Luigi, Dagster, Prefect, Control M, and there's a couple of other ones. Mage is new to me. There's something now called Flight, which came out from the Lift folks. My honest assessment is, from an Airflow perspective, it's pretty much become the standard. There's almost no large enterprise company that is not running Airflow. So Airflow tends to be Airflow and. So if someone wants to run another scheduler just because they want to, at some point someone's going to put Airflow on top of it, and it may go away or it may continue to exist. It's just become the de facto standard. It's kind of like Linux, like it's just everywhere. So Airflow is in a similar position. From an Astronomer perspective, I think that's more complicated because we do compete with the cloud native providers. And when someone's paying for something, then they are going to go and look around and say, what does Dagster do and what does Prefect do? So we find that competitively more than I think Airflow would. But Mage is a new one for me. I actually haven't encountered it.
Yeah, because I know that they market themselves as the new Airflow. So I was wondering how you see it.
Yeah, and a lot of it is one of the things. A lot of people really didn't like this operator mechanism. So that's actually why Dagster was created. Dagster was created to fix this problem, to change the syntax. And then afterwards, the Airflow community, I think this came out in version 2, was the @task decorator. So it fixes some of the things, some of the criticisms that have been leveled at it, like passing large data between tasks is a known problem. It's a thing. So there are ways of fixing it. So we, as Airflow, we plug that as Astronomer. We have mechanisms that even in your local instance, you can fix it. So I guess a lot of it is someone has created something because they didn't like how Airflow worked. And it's either a problem big enough that the Airflow community fix it and patch it and update Airflow to accommodate this, or assume it's an edge case and let someone else do that thing and do that thing well. So it means that Airflow still exists in the ecosystem, but it may touch on something else. A good example of that is Metaflow. So Metaflow is the machine learning orchestration tool that came out of Netflix. It's very much focused on doing machine learning, and they created a lot of we're better than Airflow stuff, but they've actually kind of said, you know what, we're going to go and create a mechanism to build DAGs that will run Metaflow. So keep your Airflow because it's doing everything else. Don't get rid of it. Here's how you can run Metaflow with Airflow. So it's kind of like cron. It is cron, but it's like fancy cron. So you're not going to have something that's a better scheduler on a Linux system. And in the data space, there isn't a better scheduler than Airflow. There are just other things that you would use with Airflow, and Mage will probably be one of them.
Yeah, right. You also quickly mentioned the certification.
Yeah.
I was wondering, does that focus more on the Apache Airflow side or also a lot on the Astronomer part?
So it uses the Airflow CLI, Astro CLI, but it's an Airflow certification. So it's like Airflow fundamentals and advanced Airflow. So it's translatable. The one thing about the way Astronomer runs Airflow is anything that will run in open source Airflow will run on Astronomer. So the certification there is on how to write DAGs and how to understand Airflow better. So it's an open source relevant certification.
All right, cool. Check if there are any. I don't see any other questions at the moment. All right. Well, Jeff, thank you very much for your time and for this cool talk. For sure, gonna play around with Astro tomorrow morning. Thank you again. And well, we were talking about maybe doing a second meetup with regards to Airflow.
Yeah.
So for everybody else who's watching, if you're interested, hopefully we can plan a in-person meetup in the upcoming months, and hope to see you over there. And thank you again, Jeff, for your time.
Cool, and thank you very much for inviting me. It was great.
All right, thank you.
Okay.
Bye-bye. Have a good evening.
Bye.